We know how to calculate the angle theta from the center line to a fringe. But how can we calculate the distance between the fringes, which is uniform in this situation? We're going to exploit a shortcut, and that is, for small angles, sine of an angle is very close to the tangent ratio. This way we can use our old formula to try and calculate the distance between fringes. So x is the distance from the center line to the nth fringe, and L is the distance from my source to the screen. So I can now make this substitution, and using this formula, I'm going to be able to calculate delta x fairly simply, in particular since it's constant. And so my first delta x, my first distance between fringes, is equal to 3/2 of a wavelength divided by the distance between my point sources, subtract half of a wavelength divided by the distance between my sources. That's going to be the delta x between my first and second order fringe. And of course, that is just equal to lambda over d. If I were to repeat that calculation for each fringe, I'm going to end up with the same result every time. And that is the wavelength divided by the distance between the two fringes. It's going to be the same for each one of those fringes. I can come up with a final formula to summarize that because it's the same every time. The distance between fringes divided by the distance from the source to the screen is equal to the wavelength divided by the distance between the two sources. And that's my final formula.